Okay, it's recording. So, hello everyone. It's quite a challenge to present scientific communications in less than 2 hours. So, just see this as an introduction or some hints that I want to share with you. So, as Odile said in my bio, I started research around about 25 years ago. So I made many presentations, and I was always a bit frustrated when I went to conferences. I don't know if some of you have already been to a conference, but in any case, you will soon. That I didn't understand most of what the people were saying. And I think the reality is that 95% at least of the presentations are not understandable because people didn't do the job to really prepare it and think about how to pass the message. Okay? And so the way I like to do this is give you some theory, but I don't like it to be only theory. I like to interact with you with examples. That's why I asked you to prepare this small homework. And the first point when you make a presentation is don't do it at the last minute, okay? And I know why you're laughing, because I received one presentation yesterday, 5 this morning, so at 8:45 I had 6 presentations out of 11. And they were all sent this morning, okay? So very bad practice. Yeah, because you don't have time to really think about it. You just do a first thing, you don't get back on it. And so I prepared this 2 weeks ago. Then I went back on it several times. Even if I do this, it's a serious job for me. So I want to do it seriously for you. So to start and be interactive, I will not start with theory. I will start with example. So I will take this example, which was so 6 is, who is this 6? Olga, okay? So Olga, you have 2-3 minutes to present your topic. And so I asked, for those who don't know, I asked the students to make just one slide to present the topic of their PhD, okay? And what I'm going to do is I'm going to let you do it, Olga, and then I'm going to leave the room, make comments. So what you need to do, guys, is to say, do I understand the topic? What are my suggestions? How would I do it, etc. No, it's important that you know that there is no shame in doing it wrong or not doing it well. We are all learning, okay? I'm also learning. Even after 25 years, I always question myself, was this really the best way to do it? Can I do it better, okay? So I would say, be ready to question the way you do it. If you're not, then you won't learn anything today. And be open and don't criticize others just to give advices and ideas, okay? So, Olga, others will do it, but I'm sorry I started with you, so please go ahead.
Please,
you can go there if you want. And remember, you have maximum 3 minutes, huh? So it has to be okay, fine.
Oh, yes, okay. Where is my topic? And as you probably know, seismic is widely used, but usually it is used in a very large scale, like in oil and gas, where wells are kilometers long. And also can be used for seismology, in seismology stuff. And yes, large is also very huge there. But also now the field of to use seismic exists. It's small scales, geophysics for cultural heritage reasons, for example. And the aim of this project is to determine if usual methods which are usually used for a very large scale, like oil and gas and seismology, are applicable for a smaller scale of civil engineering, cultural heritage reasons, etc. And also to test some methods, and some tools, like very modern tools which have already been used for large-scale assessment, like DAS and LEMS. And there are a lot of possible problems, like, for example, a gauge length, it's very small in comparison with a very long 2 kilometers flow. But in comparison with a 20 meters flow, it's not so small and it will affect a lot. Yes, and there is a number of problems like this. That's it.
Thank you, Olga. So, can I ask you to make some comments? Like, did you understand well the topic? What would be your suggestion? What do you think about the slide, visual aspects of it?
I usually, when I don't see figure,
Yes.
I can follow.
You mean pictures or figures? Or whatever, pictures, you mean
Like
graphical
this,
elements.
I can't follow.
Okay. Thank you. Other comments? Yes.
Yes, a comment I also received a lot is that I was trying to both read and also listen to you. I cannot do both at the same time.
Okay.
Yeah, you can a bit out text.
This is all elements I will talk about after, but I like you to already express these. Laura?
So what I liked in the beginning is that you had a graphical element that seemed to indicate a logical flow from the left to the right. So when you were talking, I was trying to follow the flow, and at the beginning I could, but then I was a little bit lost, especially because there's more text below, and then it was a little bit difficult for me to connect. Where are you? Are you still explaining the flow, or are you already down there? So I think if you have an element like that, which I think is maybe a good idea, then I suggest to maybe adhere to it. And overall, participants had maybe still reduce the amount of text, because for such a short presentation, I think if you have shorter points, people spend less time reading, and then they have an easier time.
I also made a comment about this for myself.
Sure.
Because my English teacher always says that I should connect my speech and everything which is on the slides, and I never do it.
But I will discuss that later. I just have some comments and maybe have comment by Sheila.
You go a little more loudly.
Okay. So I'm not going to do that the whole session. I have other stuff to do, but you already see that you have feedback from people in the room. It's not a professor or something who's saying. So it means that you didn't reach the audience. I mean, you could do much better to reach your audience and explain your topic. We think about visual elements, maybe doing some animation so that your information comes, gradually, because otherwise people will read and not be at the same time as you were saying, there's maybe too much text, so we will come back to that. But thank you for doing the exercise and for being the first one. Okay, I will do a second one, quick one, and then I will move to the theory. So this one,
It's UPS.
okay, so go ahead.
So, hi, I'm Jasmine. So my PhD topic is to apply compressed sensing to different applications. So I try to make it simple. So the idea of compressed sensing is to take a fewer measurements from the beginning instead of the traditional way. I try to make the importance of this research because it is so important for structural health monitoring. So what we're going to get from compressed sensing is to have a lower data rate and to reduce the data size, faster measurements, faster for the acquisition system. But we need to build a framework according to the application. That's it.
Okay, thank you. So first a comment. Already from the previous presentation, you see that there are a bit more visual aspects. So you see there are some things here illustrating the applications, and there is a big visual about the targets. Okay, so it's a bit more visual. So you have other comments or share with me?
Maybe also this was for Olga, like facing the audience and making eye contact would be very important. So Jasmine does it already, but like, let's say half of the time you still watch, you still look at the slide. A good tip would be to select 3 people in the audience and then basically go through all of 3 until you learn how to actually try to look at all eyes.
Okay. Any other additional comment? Yes.
Still too much text.
Much text.
Small
And small, yes.
Okay.
No other comment? Yes.
Fast.
Okay.
Yeah.
Sorry, all of that.
Yeah.
Okay.
You like the topic, you're passionate about it, but terms.
Okay. Well, yeah.
Yeah. So we've seen, assertion evidence presentation. So it's very nice to move the template that was given to you. I think after this lecture, we should improve our template. But there is something you need to put on your template. I'm sorry, it's the ULB flag.
Yeah,
Okay.
sorry.
It's
But I will discuss that later.
very
as well.
small,
I
very
have-
small, but in case we need just this small
Yeah, you're right.
European plan. But it should be very.
Okay, but that was, yeah, I didn't say that they had to have a formal framework, but we will discuss template after.
Yeah.
But it's really, first of all, thank you. I think I will move on to the lecture. Thank you for. I like to do it this way because I think it's maybe highlights for you better the mistakes or the ways it can be done, and then my theory maybe makes more sense than just putting it like this out of nowhere. So we will make some more after, but I want to let's say diversify. So my perspective about, I'm sorry, I have to juggle with my USBs because I had to go through my phone and then I have to charge my phone, so it's a bit complicated. So I'll do it. So my philosophy about scientific presentations is that what is really the most important, whether it's in a report, a poster, a presentation, is graphs and illustration. And this is because they are, for me, the skeleton of your communication. And if you do them well, you can use them both, presentation, reports, poster, whatever. They have to be well done. So my first thought will be about graphs and illustrations, because I think it's very, very important. So I want to talk about images and emotions. Of course, this is publicity, advertising. This is not science. But like whenever you see this picture, how do you feel?
Cool.
Maybe you want to drink a coffee, like having a good coffee. Okay. Any other emotions rising from that? Yeah.
Relax, yeah, calm.
Relax, yeah. So you see this image, it conveys emotions. There is colors. Of course, the guy is also very well known, very handsome. All this brings to it. Okay. Now you also have maybe for perfume. You see, this is publicity for perfume. This is two different perfumes, two different images. This is done for a wild guy, so it's dark, and even the letters are, treated like this. This is done to be soft. Miss Dior with, like much more colorful pink, etc. So completely different. So you see that pictures, images, even looks of people, they convey emotions. And I'm convinced that if you want to do a good presentation, even if it's scientific, you have to convey emotions to people. You have to have people liking what you say, seeing that you're passionate, that what you do is interesting. If you do everything in one color, very, not really fun with, people will not be interested. Okay. So another example is, this is a poster. Okay. Do you find this attractive? If you go to a conference, you have poster sessions and you just wander around. And usually you're attracted by a poster and you want to go see it. If I see a poster like that, I'm not going to go look at it. Just, okay, this guy is a specialist of bar charts. That's interesting. And by the time you read the title, you're already out of time, huh? Because it's so complicated. Okay. So this is another example. At least you have a catch-up phrase at the top. At least you have a picture of birds, so you know it's talking about birds. And if you're a fan of birds, you can go and look at the poster. Okay. So it is clear that we need to be attracted by things visually, otherwise we lose interest. That's what I want to convince you of. Now, you guys, the young guys, at least in the room, you are a new generation in the sense that you have been born with social networks, basically, at least from your child. We have not, okay? So in our time, previous millennium, images were not that important. We didn't communicate that much with images. But now if you go to social networks, if you have a post with only text, nobody will read it. So you attract people's eyes with the pictures. And even for science, this is an example of an Instagram account of Chiara, but she's talking about, okay, dynamics of a bridge, whatever. But she has a big picture, and that's what attracts the eye. If you use on LinkedIn, this is Fabrizio Scarpa work. Okay, you have a bit of text and you can see more, but the main thing is images to attract your eye to talk about what it is. Okay, so basically it's good because these social networks, I think they make us put more, they should draw us to put more images and less text, and even it's a reality. But sadly, scientists have not moved so much in that direction. They still think that it's good to put a lot of text, a lot of equations, etc. to communicate. Okay. So I think that there is a big power to illustrations, and I want to give you, of course, very bad examples to start. So if I want to talk about structural health monitoring of building, I could tell you, oh, the building is assumed to be excited by the wind. This causes vibrations, which can be measured with dedicated sensors such as accelerometers or strain sensors. You're already probably all sleeping when I start this first sentence. Okay, then I can put I will not read it too long. Second sentence, third sentence. It's boring. Nobody knows what's going on. So why would you do that? So a good idea would be to have a picture, because based on this picture, you can talk. You say, oh, I consider a building. Okay, this is visual. It's a building. It's excited by the wind. I show that the wind is making it vibrate. And then I said that there is an SHM system with accelerometers and strain sensors. And based on that, I do visually, there could be an alarm to say that there is damage here. Okay? But with a simple illustration that I made in maybe 10 minutes, I can really give visual support to what I'm saying and make it lively, and maybe I can add something. So I think that even in a report, it's good to have illustrations to support your main, for example, the methodology. Okay, make a schematics. I start from this, I do this and do this, or the main physical principle that you're talking about. Always good to have visual, even in reports. And in presentation, you should really replace text as much as possible by visual. Of course, it's safe to put text on the slide, because then you think, okay, I know what I have to say, it's on the slide. Okay? And then you read it like this. So first, you're not looking at your audience. Okay, not good. And secondly, they are probably reading faster or slower than you. So as you said, I think they will not really listen to you. They will try to read at the same time. So it's a very bad habit to do that. Okay, so a picture is worth 1,000 words. This is something that was done by one of my former PhD and postdoc students. The guy was very good in graphics. Maybe not all of you can reach this kind of level with 3D, etc. But he wanted to explain the monitoring with embedded sensors. And so he did the drawing. He put numbers to say, okay, I start from the acquisition system. It generates a pulse here, goes to the emitter, the wave travels. So he puts the wave here, gets to the receiver, gets to an amplifier, and then back to the acquisition card to measure the received signal. And with a simple drawing like that, I can explain very efficiently what the system is doing. Okay? Now, if you want to do illustrations, you have to know, in my perspective, the difference between vectorial and pixel graphics. Who knows this difference in this room? Difference between pixel and vectorial graphics. Okay, so not half of the room knows the difference. And I think it's super important to know it. I think the ones who know it know that it's super important, but the ones who don't understand the importance. So what is it? So pixel graphics is, as the name says, the graphics is defined by pixels. So there is a certain resolution with pixels, and each pixel has information, which is basically the color of the pixel. Okay? And the fact is that you see here, you see those pixels. And if you, I will show on the next slide, if you enlarge, you start seeing the pixels bigger and bigger. Vectorial graphics is when the graphic is made of graphical objects, like lines, circles, spline functions, whatever. So a line is defined basically by 2 points, maybe the width of the line and the color of the line if you go to color objects. Okay. So what difference does it make? If my letter here is defined by these curves, if I enlarge it, it will be processed by the computer, and it will still look like a very nice curve. This one, it's a bit exaggerated. That doesn't look that bad usually. But if you enlarge that, it looks very bad because it just makes bigger and bigger points like that. Okay. So pixel image is typically JPEG, PNG, GIF, TIFF, and it's used by softwares like post-process them. Photoshop, GIMP is a free version of Photoshop, quite a good software. And Paint is the basic stuff that you get on Windows. I don't know what they have on Mac, but you know, this is the type of stuff. And if I make, this is one drawing for my courses, for example, if I make this with a JPEG of 100 dots per inch, this is what it gives. So it's a bit ugly, the resolution's not good, and you see these shadows around the things. That's also due to the JPEG filters, but also due to the low resolution. And the size is 65 kilobytes. Okay. Now, if I use vector graphics, this is the main one is SVG, so it's for standard vector graphics. That's like the standard, let's say. But then if you have a PostScript, good PDF, because it depends on how you build your PDF. Adobe Illustrator, CorelDRAW, they all make vector graphics. Okay, and I usually do all my stuff in vector graphics, and if I use SVG, nowadays it's possible to put SVG in PowerPoint. It works most of the time. And the size is 5 kilobytes. Why? Because all I store is different points of my rectangles. It's very simple geometry, so it takes almost no space. And I have much better results than with this here. Okay. I think that's from the computer. I don't know how you close it. So, you have to go back to the Zoom. Yeah.
Sorry, no.
Yes.
Can you go back to one slide?
Yes.
So for me, when you said like this is not looking that nice, or it's like it doesn't look that bad, but then it's easier to see when you present the tutorial on the side. So I was wondering, what do you do in case you don't have the tutorial?
Yeah, I will show that after, but you use higher resolution. Just the size of your file will be larger. Yeah. But I will explain that after. So the question is when to use one or the other. I think that when you have simple lines like figures like that you get from MATLAB or Python or whatever, or just lines, it's really nice to have vector graphics because it takes not much space. Okay, so for schematics, drawings, geometric point lines, etc., arrows, you use that. I advise you use that. And the main advantage is the small size, and it can. I will demonstrate that it can be easily modified. That's one of the main interest of vectoral graphics as well. Now, if you have pictures like this, you don't go to vector graphics. There is no way to represent a picture that was taken by a camera with pixels with vectors. It's a complete nonsense. Okay, so in this case, you will use, and I will come back to that, but this is compatible with most software. Okay, so most modern presentation software, it was not like that in the past, but they will use both. Okay. So for example, LaTeX, historically, you could only put vectoral stuff, EPS, etc. When you were struggling with JPEG, you had to put a header. It was a nightmare. All people in the room remember, but now you can just use with the PDF, LaTeX to PDF, you can use whatever you want. It works fine. And Word and PowerPoint initially were pixel-based, and now you can start to introduce some SVG vectoral graphics in that. So, but everything like social media, web pages, they are still in pixel-based. They're starting a bit on web pages to have SVG, but it's really not established as a way to do it. So what I advise is whenever you can do vector graphics, do it in a vectoral graphic software, keep the original file. And if you need to put on a web page, export to JPEG or PNG, whatever. If you don't want to use SVG in PowerPoint, export to JPEG, but with a good resolution. So I'm a bit picky, but I think 600 dpi really makes a good job. 300 is still acceptable, but if you go below, as I showed, it doesn't work very well. But this is example, I exaggerated. Okay, I probably took 1200 dpi, but you see that then my size is quite large, it's 500K compared to the SVG, which is 5K, but you don't see the difference.
I'll just make one comment here. In addition to just using JPEG for pixel graphic, I recommend PNG, especially for images like this, because PNG is sort of made much more for such illustrations, whereas JPEG is more made for natural images.
You mean the filters are more fit to lines, etc.
Right. There's actually a lossless
yeah.
version of PNG, which does not have the JPEG compression artifacts. So I think for images like this, it's a better choice.
But if I may, an important comment. So please choose a very high resolution. So if you choose something similar to what at the end of the screen will be, you get these artifacts because of the upscaling. So if you have, let's say, 800 and now you need the 1024, it's gonna look really bad. So just go overkill and choose a very high resolution so that it's more downsampling instead, which will look decently.
Okay, so just to show you what vectorial graphic looks like. So this is, I don't use it much, but I can demonstrate some basic stuff very quickly. This is Inkscape. Inkscape is a free open source, I think, or at least open software. So you can download it for free, and it will open your PDFs, EPS, whatever you export from the software. And so what you see is that then I have objects here. Everything is an object. If I want to change the color, I can go here. This is for the center. I can make it yellow. And for this one, here, I can change the contour line, etc. I can move objects, change line width, etc. So very simple. And what you can do is if you have, for example, this is an EPS exported from MATLAB. If I open it with Inkscape, works. Oh, sorry, I don't know what happened. It wasn't working yesterday, so that's always the demo effect.
The
Maybe I use
Inkscape
a,
logo is blinking.
maybe I use a minute to say another couple of comments, if I may. So watch out that PDF sometimes contains actually bitmap data. So it's not always a vector. So for example, if you scan a document and you open the PDF, it's gonna be actually a bitmap inside. There's also AI upscaling that you can try if you have a figure that looks bad and you cannot just recreate it somehow. You can also try an AI upscaler. I'm sorry? I'm not sure. Actually, I don't know what they're using as a model, but there's a whole bunch, and I think it depends if it's a photograph or if it's, for example, something like text. It's going to be different model, I would expect. And I don't know if you will talk about having a LaTeX in your vector graphics.
No, I think it's too much for today. Maybe we can discuss that at coffee break, etc. So I remember why it didn't work, because I needed to open the PDF. So if you generate a PDF from MATLAB, it will be vector graphic. So it will be vector object, not font. So if I open it here in Inkscape, this is what I get. And usually when you start, everything is together. So if you click right, I'm sorry, it's in French, but you dissociate the elements. And then you can really start changing things like here, the color of my line, I can put it in yellow, do stuff like that, okay? So it means it's a simple post-processing of your figures that you export from any software, Python, if you do it properly. Because if you export in PNG or JPEG, of course, changing color is possible, but it's a lot of work. You have to really understand Photoshop, and okay, it's complicated. Okay, so.
But sorry, I'm not going to ask a question.
Yes.
Sorry, a stupid question. But
no question is stupid.
Yeah. But the image was imported as a pixel one, or already as a.
No, this is a vector. So this one was created by MATLAB, exported in a vectorial format.
Exported in a vector.
Yeah.
Okay.
So PDF is natively vectorial. It has objects inside.
So already MATLAB
gives you that. If you do a print minus dpdf, it's the command line MATLAB. You put it. There is also minus the SVG if you want to use the standard vector graphic, minus the EPS for PostScript. If you put minus the PNG, you have a PNG.
Right.
And I'm assuming, not specialist with Python, but I'm assuming Python has the same kind of libraries to export in all kinds of.
Right. So
the good practice is to export it in vectorial, because then you can work on it much easier, modify some things.
Once you choose the format, the export format from MATLAB, there you choose if you want it JPG. I mean, because I've always exported in PNG, right?
I know, that's why I'm explaining this.
Exactly.
Because
that's why
a lot of presentation about communication, oh, do this, it's very nice. No, I want also to show you how to do it.
Exactly. So I
Because-
can export it directly in, let's say, SVG, and
Yes,
I can solve,
for example,
let's say,
you use Inkscape, it's free, or if you have the Adobe Suite, you do Adobe Illustrator, very powerful, but more difficult to use.
because Inkscape, sorry for this.
No, it's okay.
With the Inkscape, because this Inkscape is,
It's a free software.
yeah, it's a free software to work on that vectorial image.
Yes. And then from that, you can export in any format. You can
Yeah.
export in JPEG for your, if you like to put JPEG on a website. You can change the resolution. If you're going to go for a smartphone thing, you don't need a 5 megabyte image. If you go to a presentation, you use a bit more
Because
DPI.
obviously, if you work on that image, I mean, with Paint, it's a,
With Paint, it's pixel based. So if you're going to, and it's difficult to change colors of just this in Paint. And good luck, huh?
yeah.
I don't know.
yeah.
I don't know if anybody can do that. Yeah, you can paint by hand. Or
Yeah,
I can't.
why do you say that on a website? We should, put it as a JPEG.
Because usually when you make a website, it will, your interface will only accept
JPEG.
pixel, not JPEG, but pixel based. There are some modules now which integrate SVG, but not common practice. Maybe you have to put an add-on to your WordPress or something to do it. I don't know. I then try not to do it because I think it's not yet
I believe you.
working out.
The fact that web engines
Yeah.
operator compatible for devices.
Just one more suggestion in terms of a shortcut. If you don't have a super old version of MATLAB, this has worked 10 years ago, so it works for a recent version of MATLAB. In fact, when you have your figure open, you can do copy figure and you can choose whether you want to copy it as a bitmap or as a vector. And then if you just
And then you
paste that
paste it
in
in there.
PowerPoint, you will actually have a vector graphic. So you
Okay.
don't even.
I didn't know that, so thanks for
And
sharing.
then you can in fact ungroup, and then you have the separate elements and you can drag them apart like we showed.
So you, in that case, you just don't have to go there in the export
You wouldn't need
settings.
to, right.
And you would be able to modify it directly in the PowerPoint. Now, I don't strongly advise that because I think PowerPoint is not that easy for some aspect of what you can do with the vector graphics. But if you feel comfortable doing that, then it's also a possibility. Okay. Okay, so back to the presentation. Yeah. Yeah, sorry. Back to work. Okay, so this was the example that was created with CorelDRAW. At the time I was working with CorelDRAW and then exported to JPEG with high resolution. Okay, now I want to stress also the idea that these tools are also there to make your own illustrations, and I would like to tell you why. So this is an example. I told you I did many things in my life, so I worked on this composite piezoelectric transducer more than 15 years ago, I think. And they are made from the company Smart Materials. So if you want, and they have a certain layout with different layers. So I'm not going into the details of what it is, but if I wanted to present that, I could go on the website of Smart Material, download it and put it there. But you already see that there is a bad resolution, okay? Because it's a web image, and web pages are made to be loaded fast, and so they have low resolution images just to be seen on small screens. Okay. Also, maybe it's not optimal for your report or for your presentation because there is all this stuff around that maybe you don't need. You want to show something else. And obviously, if you want to work on a pixel-based image and remove those arrows which go into the drawing, it's doable, but it will take a lot of time. Okay. So what I did, I redid this at the time in CorelDRAW. So you can do 3D images and these vector graphics. You can make a rectangle, export and extrude it, make a 3D element. So it's not limited to 2D images. So I did that. I can choose the colors that I want. I can choose to put what I want. If I need to modify it very quick, I go into the software and I say, okay, just change the text here, and I re-export it. Okay. Now we talked about illustrations, and I tried to convince you that vector graphics is a good way to do it. Now I want to talk about graphs. Of course, there is a lot of things about graphs. There is first choose the right type of graph. Okay. For that, I'm not going into detail today, but there is a video, a link to a video at the end of the presentation where it discusses the kind of graph that is made by another guy, Jean-Luc Dubon, who's a specialist into science communication. And I think if you get the time, maybe watch this presentation. Of course, this is basics, but still sometimes you see access without labels and units. Okay, we're engineers, so we need to put our labels. What do we put against what? But most important, what I want to focus here in on readability of your graphs, because this is often a nightmare. Okay, so there's two aspects to readability. The first one is that you have to be able to read. And most of the time, you have such small fonts that you can't even read what's on the graph. But also, it's not just about plotting X versus Y, it's about highlighting the information, or helping the audience to understand what they should see in this graph, okay? Because they don't have time. You're going to spend 30 seconds on the graph. They don't have time to think, oh, what does it mean, this curve actually? So you have to help them do that. So my advice is for the readability, stay away from default configurations, okay? This is an example of some graphs I did. I will come back to this later, but this is profoundly remastered from the MATLAB output, as you see. I think MATLAB never gives you an output like that. So I take an example. This is for those of you who know dynamics. These are the mode shapes of a cantilever beam, okay? And if I use MATLAB to do that, this is what I get. Initial MATLAB figure. This is awful, okay? Why is this awful? I can't read. This is all very small. I don't know what's there. I don't know what's there. And also, you look at what is the information. The information is those lines. They're the same thickness, same color than all the big box around. So you don't know where to look. You don't know what is interesting to you. No, what you can do is already increase the line width. Oh, sorry, the pointer's not working on TV. And increase font size. This you can do already in MATLAB or Python. There are some commands, or if you like to use the GUI, you go in the GUI change, etc. But you can do automated set font size, etc. If you need the command lines, I can share with you how to do that. Just tricks. And then automatically you change the font size to something more readable, and you increase line width, so you see a bit better already the information. But you can also, of course, here it was put all over the place, so you can reorganize. And you can change axis style, because the axis style of MATLAB is a box. And as engineers, we are more used to XY axis. Okay. So this, first of all, you can do it in MATLAB, but I never found a way to have the arrow. So I can show you mine. Okay, so good. I can get
Yes.
But so you can really remove the box around, just keep the axis. You can even put the axis at 0 if you prefer for sometimes, okay? And then you export. And then adding the arrow is like 1 minute in a vectorial graphic. And you go to the line and you change the end line to an arrow. So that's the way I did it. If there is a trick in MATLAB, I'm happy to hear about
All
it.
those things you can do command line in one.
Of course, but you can do everything command line. You can also write mode 1 here, mode 3 here, etc. But sometimes it becomes tricky because positioning your thing in the graphic takes more time than going to the vectorial graphic and writing. But
Although one comment in favor of the command line, which I strongly would suggest to learn, is that if now you find out, oh, I missed something or I should have changed something,
yes.
Then you can just rerun the MATLAB and you get the figure complete, which is much, much better than having a manual step. So I would speak strongly against having a manual step.
So maybe we can divert a bit to that.
Okay.
So I think that the best way when you want to write a report, etc., I'm sorry to say, but it's to use LaTeX.
Yeah.
Because in LaTeX you have you can include your graphics with the name of the figure, and if you have an automated script that generates your figures based on your data, you just run your script, recompile your LaTeX, and it's up to date. Sure. And as you said, if you made a mistake in the post-processing, you forgot one parameter, just change it in your processing file, generates it, and you don't have anything to do. The more you can do in the command line, if you can do everything, that's really the perfect way, because then it's all automated, all updated, makes you gain huge amount of time. Okay. So that's then I also rearrange a little bit. So, I mean, what I did basically in a few steps, whether you do it command line in the vectorial graphics, just that's tricks to do it. At least graphically, I think you understand that this is much better than this. I hope you see that. You find it better. Otherwise, I can go home and just stop. Okay. And most of the time, I just see this all the time. Okay. That's, to me, that's not good. That's not a good way to present your book. Okay. So what about legends, for example? The default of legend is like that. I'm not a very big fan of legend like that, because every time you have to see, say, okay, what's the red line? Ah, it's a sine. Or here it's not, but what's a green line? Ah, it's a cosine. What's the black line? Ah, it's a line. Okay. Now, if you do it like this, it's much easier. You look and you see directly, this is a cosine, this is a line. So whenever you can, maybe put your legend in the graph. It's much more readable.
You have to do this, not in MATLAB.
You can,
but
but it's tricky because placing these, for example, arrows, etc.
you have to put a
You
line.
have to put a location compared to the size of the thing.
And it has
I mean,
strict coordinates.
For guys who like programming, it's fine. If you're not a big fan of programming, do it in the vector graphic programming. It's up to you. Okay. So this is examples of presentation I've had throughout the year with my students. A very bad use of legend. Okay. Because what you want to highlight is exactly what is behind the legend of the graph. You just put legend in MATLAB and they were happy with that. By the way, there is some options in MATLAB to put your legend on the bottom, on the left, even on the northwest. It's geographical locations. Okay. Now, also, I want to say that your graph is used to tell a story. And it's important to choose your colors, etc. So this example, I'm not being very clear on purpose. You will see after a while. This is an example of piezoelectric transducers where we use composite inside. Okay, and the matrix can be made either of PU, which is polyurethane, epoxy, cement, and then you have the bulk material, so just the piezo. Okay, so how is the color code? First of all, it was my postdoc, the very good guy in graphics, I really like him. He decided for PU metric to use blue, but you use different shades of blue depending on the percentage of matrix in the composite. So that's very visual. You know that everything is blue means PU, and you see the difference in percentage with the shading of the color. For epoxy, it shows green, and for cement, it shows yellow. So that's very nice because usually you see that there are 3 categories with different shades, and you already get information. So as you saw, I didn't put the legend there because you would have had 7 or 8 lines, and tomorrow you're still reading the legend and trying to figure out what each line means. Okay. So he put it directly there so we can see and relate. And then he put information. He says, this is the first axial mode here. So you can see that for epoxy and PU, they are around 220 kilohertz. But for cement, they're quite higher, around 300. And you see that the bulk element has a much lower frequency here. Okay. So just by playing on the colors, on the shading of the colors, putting some information, this is already much more readable. But there is a problem with doing that. The problem is that we don't know what we're talking about. And that's a mistake I see often. You put a graph and you don't say what you're talking about. So when you use a graph, put a picture next to it. A schematic, something. What are we talking about? So here, this is a radial piezoelectric element, just a disk. And this is showing that I'm using a finite element with just one part because I can use cyclic boundary conditions to simplify the computation. So it shows that this is numerical results because I show you a numerical model. It shows and I can talk about what it is, showing you what it is. Okay? So don't put just a graph on a slide. Put always something next to it so we can relate. What are we talking about? So this is an example of telling a story simply with combination of graphs and figures. So you already understood that I work on embedded transducers. So this test was about testing a concrete specimen on a 3-point bending test. So 2 supports and 1 force in the middle. And so the picture here shows you that it's real. It was done in the lab and there is something real. So use pictures. When you do tests, show us the lab, show us what's going on in your test. And there was some information like the size of the specimen. But what I could not put on the picture easily is where the transducers are because they're embedded. Okay, so they're not be seen. So I choose, and it was again my postdoc who did the graphic, to make a nice graphic here where I see the transducer inside and the distance. So I add information with my illustration, which I cannot put on the picture. And then what I want to show is that with these transducers, I'm loading the specimen, it's going to crack, okay? And I'm plotting a damage indicator. I'm not telling you now how I compute this. This is just a basic concept. And this is my damage indicator. There's two damage indicators that are plotted. And then if I was just using this figure, I could just tell you, oh, you see that with time, there is some damage, and then the damage goes down, okay? But if I really want to explain you what is going on, I need to give you more information. I have to plot, what I chose to plot is the force displacement curve. So I have a force, what is the displacement in the middle? Why? Because a force displacement curve allows you to see that in the first stage, you're in a linear, well, pretty linear, the machine is not that wonderful, but you're in a linear stage, so you're in elasticity, you don't have any damage. And at some point, it starts to damage, so it goes down. So I'm putting some points. One is until linearity. Then is when 2 is when I have some damage. And then you see that after 2, the load decreases. What does it mean? It means I started unloading my specimen. And when I unload my specimen, what happens? The crack, they start closing, but they don't repair completely. So that's why after that, the damage indicator decreases, but at some point when it's fully unloaded, it will stay at a certain value because there is still crack in the specimen, okay? So you see that without any equation here, I was able to tell you a story that I think you understood. Okay, but all the information that is on this graph is important. The picture is important, the illustration to see where the transducers are. And on top of this, these control points, 1, 2, and 3, are important to tell the story because they refer to different regimes of the loading and the damage to explain the story. Okay? So that is what is putting information. So the question you will ask is all the important information present here on the graph? Okay, we'll go to pictures. I had a student in the—
Sorry, can I ask a question?
Yeah.
What do you think about doing things directly in PowerPoint? I mean, sometimes I've, I had the plots, and I would like to highlight a part of the plot. So for instance, I made a circle or
yes, you can do that. Of course, you can.
With a little bit of shadows and an arrow. So
I think it is a very good practice to do these small items in PowerPoint because then you can animate. It means you can first show your graph. Oh, this is my graph. And by the way, look at this zone. Then you make the circle appear. This is this zone. And then now we're going to look at the second zone. Then you click and you have the second zone appear.
And again, it's something to do easier than in MATLAB, because in MATLAB, let's say to put an arrow, you should coordinates or to put a circle.
And you have the advantage to be able to animate. I think I will come back to animation in the second part of this talk, but this is, no, it's good because we highlight already important things like animation, which makes your talk more
And I think it's a matter of efficiency. If you realize that you can do something in PowerPoint in 3 minutes that in another program would take you 30 minutes, it's probably a very good idea to do it because you're always going to have limited time budget. So you need to find a tool that gets the job done most efficiently, also for you. And in fact, if you do a graphic in PowerPoint, even you can export it from PowerPoint in a vector graphic format. So it's not lost. You can actually use the data. So it can be, for the things that PowerPoint do, which is limited, it can be a good tool.
Yeah.
So I think the main message here was use vectorial graphics, but whatever way you do it, it's up to you. If you like to program in MATLAB, if you like to do in a vector or in PowerPoint, but you will see the limitation. I think it's when you see that you're limited that you start looking for other solutions.
Yeah. Sorry. And to create my own illustration in vectoral imaging, you suggest to use the same to modify the Adobe Illustration.
Yeah.
The same to create the full image.
Yeah. So every vectorial graphic software is okay. If you are familiar with Adobe Illustrator, it's a wonderful software, but you have to pay for it or crack it. And Inkscape, I'm mentioning it because
Yeah.
You have to take that as the recording, the
But many universities, I think, have licenses So
Yeah,
should
you
check
can
if
get the
you-
license through your
it might be that
university.
for example, our university has the full cloud.
Yeah,
for
but
student.
not, I can tell you not everyone. We don't have it
So
for
you,
exclusive.
you might not know that actually you can use it legally, which we all agree that it's the right way to do.
Okay, I see that time is running, so I will come back to the presentation. I want to talk shortly about pictures. This is an example. I had a student who was in the Belgian Olympic teams of shooting, and he wanted to do his master thesis on things related to his shooting. We put a sensor on the gun, etc. It was quite fun. But then I went to take a picture of him. It was in a yellow room, a bit dark, etc. So not wonderful picture. Oh, you can work with stuff like GIMP or even apps on your phone to improve that. You can, of course, crop to just, because there's a lot of space here that's not really necessary for information. You can crop, you can adjust brightness, level, saturation, etc. to make it a bit more lively. You can also get rid of the background. I see that there are wonderful apps to do that almost automatically now on phones. You don't even have to know how to do that with Photoshop anymore. And you can even recompose if you want, whatever you want. Okay? That's picture. But the importance when you take pictures is the background. So if you look at these two pictures, you see obviously that the subject is the little girl. But it is much better picture of this than this, because there she is in the shadow. There's the big tree. It looks like it sticks out of her head. It's not a beautiful picture. This one has a blurry background, so it's much better. Okay? So pay attention to your subject. And this is an example of a picture I took. I'm a fan of photography, so that's why you can ask me a lot of questions if you want. But I took this picture in Gare du Nord in Paris one day. And I really liked, this interaction between these two musicians there. But of course, I was there and there were other people at the back, so I had to take the picture like that. And then I said, okay, how can I improve? Because my subject is these two things. Well, first I can crop, choose to make it square, for example. But if I do that, I still have this guy there that's on the back. And if you look carefully, I blurred it a little bit to make it look like there is no depth of field and it's not. Of course, the depth of field you can play when you take the picture, but sometimes you don't think about it. So, okay. So that's the way you can do it. And this is an example of my students taking a picture of a lab experiment. Okay. I mean, when you do a lab experiment, clean up. Don't leave your old tissues and your paper on the picture. Okay. First, and then secondly, they want to focus on this zone, and there is all this stuff around that's really messy. Okay? So pay attention with big pictures, clean up. It's like when you sell your house. If you put pictures on the application with all your clothes on the floor, your dirty stuff, nobody will want to buy the house. So here it's the same. Just clean up a little bit before taking the picture. So this is an example. Okay, in our lab, it was done black and white to look a bit, old, etc. But anyway. We showed the setup, and because the concrete cylinder was here and could not really be seen on the big setup, but we wanted to see the different elements of the setup, we decided to put also a zoom. Okay? So I see that too often, a big picture, small specimen in the middle, and nobody knows what's going on. If you want to show the setup and the specimen, maybe use two scales, one of the big scale and one zoom one. Okay? No, be careful about the internet. So what I want to show you here, this was for a project of students. They had to build a cochlear implant. Okay. If you want to illustrate that, you can go internet and find this. But this image doesn't belong to you. Okay. And this is a very complicated matter. I would need hours to explain you, and I don't even know everything about that. But the basics is that the way I do it is I take a picture from somewhere. I will at least cite the website, not the full link, because it's like at least we know it comes from there and there is some analogy. Okay. It's extremely difficult, even on websites, to find what are the licenses associated. It's usually not even said. But you have to know that in most cases, if you don't make a commercial product out of it, you shouldn't have too much problem. It's not completely true. I will tell you just a story. I do a lot of gymnastics, and I was doing the website of my gymnastics club. And I took it over from someone else, and I had a picture of a gymnast to illustrate something. 2 years later, I received an email from Agence France Presse saying, okay, this image is us. You owe us 10,000 euros. So you have to be careful about this thing. There is something very nice. It's called pexels.com. And all images on Pexels have a special license where basically if you don't make a commercial use, you can reproduce them and not acknowledge the author. That's even higher than CC BY in some sense. And that's what I use for all my transitions. So if you look at, for example, all these images here, because I like to make it lively, I got photos and I got pictures for illustration. I don't need to cite them, I'm free. But you have to know that this is really technical pictures. It's just, you know, ambience or whatever pictures. You don't find technical pictures. Okay, so as a summary for today, I wanted to say importance of conveying emotions, okay? And I will come back to that on the real presentation, how you do that also with the graphical aspects. And a good story is told with, I think, a proper graph and a self-made illustration and or a self-made illustration and or picture. Okay, so combining all that, doing it properly, working on it, taking the time, that's really important, but always use the right tools to do that. Okay. And this is the skeleton of your scientific communication. So my next talk will be about oral presentation and show you how we build the presentation around this skeleton of figures, illustrations, pictures. Okay. Thank you.
Thank you very much.
I would really like to make a comment that very, very strongly underlines the point that you say about a good story. And the reason I want to emphasize it again is because it's something I really notice in our students. I try to teach it to every student, and with some it sticks fast, with some it takes years until it sticks. But it's a very, very common mistake. Almost every student does in the beginning, that they start making a presentation about the result, not thinking about the story. So a very typical example is they do some simulations, a figure comes out, and then they have the figure. So they take the figure, they paste it in the PowerPoint, and they paste a lot of material. So they build, as they say, the presentation, not top down, but bottom up. Now they have a lot of material in the presentation, and they think, well, yeah, it's the results, so I should be able to explain it. But A, it's too much, so they struggle with the 5-minute time they're allotted with. And B, they open the slide, and you feel they're struggling to present it, because at the moment that they're opening it, they're struggling to find the right words. And that is the telltale sign of it's actually complicated. So the slide, instead of becoming their support, becomes their enemy, because it is very hard to explain it. And I really, really try to convey the message, don't do this, but instead go top down. So first of all, think about the story you want to tell, and then think about what is the right visual that I need to tell the story. And especially for the figures, for the illustrations of results, in almost every case, it means you redo the figure. In almost every case, it means the way you simulated it is not the way that you're going to present it later. You're going to recompose, you're going to plot in a completely different way, but you don't know yet. You only know once you think about what is the story I want to tell, or the way I usually say it, what is the message that you want to stick? So if you have an audience and you have a certain number of minutes, you can think about, okay, maybe I want to explain why the problem is important and what I did, and then I want to have a couple of messages that stick.
Well, that's the topic of my next.
Oh, I'm sorry.
It's good that you introduced it. But I will detail all that.
Okay,
I agree.
point being, yes, you need to really think about your figure, and you probably need to replot it in order to tell a story.
Yeah, and it takes. Okay, so well, I see that this topic brings a lot of questions, a lot of so I'm a bit behind schedule. I will go to the next part. I was hoping to let you guys DCs present again, but I think it's a bit short with time. But anyway, it's very good that for those of you who did take the site, I think it's very good because at least you can relate between what you did and what I'm presenting today. What I also said to Rigid is that I'm available really at some point in the network if you want to go deeper, because as I said, in 2 hours, I cannot cover everything. If there's aspects you want to interact with me on your presentations, we can organize that online or in another event or whatever. We'll see what's possible. So now I want to focus on really the oral presentation. So first, what is the importance? I think you want to avoid this, especially after lunch, because people tend to maybe have some alcohol or eat a lot and then they fall asleep. So you want to avoid this. So the question is, how are you going to have this rather than people falling asleep? So how to captivate your audience? My way of explaining is have a message. So I'm coming back to what Florian was saying. have a message is really important. Second one is make attractive slides, so make emotions, basically make it graphically attractive to people. And a very important point, what I call increased signal to noise ratio. I will explain you what that means, but for those of you in measurements, they already know the basic idea, but how you translate that. And then the last aspect, which I don't train, but which is important and was noticed in the first presentation, is your body language, your attitude when you present. Of course, it has some importance. So the question about having a message is basically what do you want to tell? And to deliver your message, you have to make a certain scenario. You have to think first before dumping all your results on PowerPoints. How am I going to tell my story? So you have to, and when you do the structure, you have to be sure that the parts are in the right order. You know, in books, it's okay maybe to start with a situation where nobody knows who is who, or in film, and then they're surprised, oh, who's this guy? We don't know. We'll discover in the next session of the film, etc. Okay? Not in science. It's no sense. If you start introducing a notion that you haven't said before, everybody is lost. Okay? And then you have to pay attention about transition. So when you go from slide 1 to 2, what is the transition? Why do I go from here to here? And that everyone to talk about, you want to talk about is there in your plan, and that in the end, this whole story makes your message clear. Okay, so what is basically, how do you build your message? That's advice. You should always start a presentation with a context, but a wide context. Okay, so jumping in, oh, I'm doing ultrasonics on the concrete, blah blah blah. Yeah, okay, but why? So maybe put a picture of a damaged bridge, damaged aircraft. What's going on in the world? Why are we doing that? Visual. Then what is the real problem or question you want to address? Be clear about that. In the literature, there is this and this, but today we still cannot do that. So what I want to address is this question. And then what is your methodology procedure? Explain how you're going to address it. And then what results did you get? But more important, what kind of information do you get from these results? Not just graphs, but what is the big outcome? And then you should finish with future actions or decisions, depending on the type of meeting, etc., perspective of your work. But what you want is that at the end of your story, your audience remembers the most important. For example, previous presentation I made, main message was use vectorial graphics. Okay, and I think you will get it. This one, I hope you will get it. Use vectorial graphics. So when I prepared my presentation, I knew this is the message I wanted to convey, guys. Use vectorial graphics. Use the right tool. One of the messages. There were a few more in the presentation. But you see, that's the idea, and to convince with proper argument. No, I had an example of presentation, but I'll go very fast over it because I don't have so much time. This is a presentation I made a few years ago, I think 6-7 years ago, and my graphical style was a bit different. It evolved with time, so you will see that now I'm doing things, so I'm still evolving, but it was called like this, so I had my introduction slide. I don't put that in presentations, just to tell you what is the context part, just to, I added that presentation. So the context is tune mass damper. What are they? So first I put a picture of buildings which are vibrating, and then the devices that are put on top to counteract these vibrations. So very visual, I'm talking about what is my problem. Then what is my question? So why do I want to address this? My question is, if I have a building, I made a schematic in CorelDRAW, and I have my tune mass damper, which is a single life system. How do I tune it? So how do I find M, K, and B? That's my question. And then I go about the method. That I will skip because it's a 20 minutes presentation. So I'm not going to make the whole presentation, but basically I'm explaining what are the equations that are currently used to do that, with some visuals to support my presentation, etc. Maybe some highlighting stuff, blah, 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 nice modes of a building. And then that's the current approach. That's my new approach. How am I going to do it? Explain how, and then make a visual to explain a bit better. And then I have my results. So in my results here, I chose to compare 3 methods and to see that the new method I'm proposing is pretty much as efficient because both curves are on top of each other. Yeah. But in the end, I apply this to a large finite element model. And what is the information? Well, I showed that there is limitations to the current approach. the two current approaches, which are analytical and full numerical. And so I propose a model reduction technique to make it more efficient. And I illustrate it, and in my illustration, what I show is that now it cost me 3 seconds, and with the full model, it was 2 days. So basically, that's one of my main messages, because I think I can convince you that if I do the same computation in 2 seconds, it's much better in 3 days than 3 days. And there is some perspective, but okay. So you see, the main, what was the main message? I try to convince you that there is a need of these devices. I show you pictures. I showed you the limitations of the two current approaches, and then I introduce a new one, and with focusing on the fact that I'm going to gain a lot of time doing that. And that's my very convincing argument. So that's what I want people to remember, that I did this and you can gain a lot of time by doing this. And so this was my message, and the question is, how do you convey these messages? How do you do it? And that's really building a presentation. Now, I want to stress the fact, and this was said yesterday and also in the presentation, is that before, when you have your message, even your message should be targeted to the type of audience that you have. Why I'm putting these pictures, because 5-6 years ago, I did a show on TV to explain what are the transducers in the tunnels, etc. But it was a general show for everybody, okay? So I needed to make, it was a pitch presentation. I had 14 visuals, 7 minutes to prepare in a virtual studio. Quite fun to do. But anyway, so I had to prepare 14 visuals, and I had to stay away from graphs, units, stuff of engineer, because my mother should be able to understand it, or my girlfriend, or someone who has no technical background, okay? And so I chose visuals. So for example, this visual shows you that the guy with his smartphone, he has sensors in the tunnel, and he has some alarm levels on the smartphone to know what's going on. So that's what people needed to know. They didn't know how I'm doing, what processing, what method I'm using. So be careful about targeting your audience. And yesterday, the project officer, she has no technical background. Most of your presentation, she didn't understand much what you were doing, because you went, except for Damien, who did a very nice presentation, because he really focused on the interest of the user without the technical details. So that's an example of targeting well the project officer in that case. Okay. So first point is make attractive slides. And for that, you need to have some graphical chart to template and layout. I know that maybe Fatima and Odile will not be very happy with me now, but I want to give my perspective on these templates. Okay? Yes. But there's some general stuff I will agree with, but some details maybe we can say. But okay, first you need to choose your font type, or which font type are you going to use. Here maybe you are restricted by the template, but in general, when you make a presentation. So you have the serif and sans serif. I don't know if you know what it means. Serif means these little things here, and this is sans serif. This is from the old time, and I found this funny on the internet. Or you have this kind of stuff. Not for scientific presentation. If you're an artist or something, maybe, but not that. So usually we prefer sans serif for. No, there's one for report and one for presentations. It's like sans serif. Properly, if I wrote it there, presentation. So it's sans serif for presentation and serif for report. But okay, you can also use sans serif for report, nobody will kill you for that. And avoid fancy fonts. Of course, very important is font size. It's not the exact font size, because it should be a bit larger scale to the screen. This is a pixel-based image, sorry, I should read that. But for example, I use usually around 24 size, okay? And sometimes a bit less, but don't go to 12. 12 is unreadable for people. Be consistent. So use same font size for same type of information. If it's a title, it's always the same font size. If it's an information on the slide, it's always the same. If it's a legend, it's always the same. And make sure it's readable. This is output from MATLAB, completely unreadable font size. Colors. This is my advice, but I like to work with just a few colors. If you are familiar with the chromatic wheel, this is the colors, and there is some matching of colors in colorimetry, for example, the opposites usually work well, or the ones that are close in the circle. For example, this is why you see often blue with orange in some graphs.
There's also sort of a movement with a number of people, their color blindness issues. Do you see that also coming up, that there's more and more attention to that or not?
So I've never seen this kind.
Apparently there's an analog to the color wheel that helps it not being confusing before, but I don't know more about it. I just heard about it.
Yeah, we actually, so red and green should be avoided. And that's when you have plots. It's a nice thing if you want to use, for example, dash lines.
Instead of colors.
On top of color. So do both, so that you actually take care that the people that are colorblind that can actually also understand it. And it's a very good idea, as you were mentioning, to have the, instead of the legend, to have the line, because at least you can now follow the line and say, aha, this is the plot.
Colorblind people.
So this also
of course,
helps
it
for
also helps.
colorblind.
I didn't think about that, but it's true. Yeah. Okay, so for example, I chose 3 colors for my presentation, and you see that everything pretty much, well, except of course the pictures, and I don't change the colors of the pictures. I thought this is not correct. I have 3 colors, and this is the RGB codes of my colors. And you have to know that in any software, even PowerPoint, you can define your RGB codes. You have to go into settings, you don't choose the default one, but you can define. In MATLAB, you can define your colors also RGB codes. So when I do a graph, I use these RGB codes to make my lines also, so that it fits to the rest. So my advice is pick a few colors, which are 3, maybe 4, but not 10, because then it's not understandable anymore. And be consistent with their use. So about the, yes.
These colors are you're suggested for specific colors?
That's my choice. That's my visual identity.
So it doesn't depend on the template, maybe.
Well, it does, but I will
the top-
explain you my perspective on template and you will understand better. But basically, don't take the same colors as me, yeah?
No.
Because you have your own identity, so choose your colors. It's your identity. It's the identity of USES2 is certain colors. They pick certain colors in all the templates, etc. Yeah, the green, the blue. So that's the identity of the project. But when I do my presentations, I like to keep my own identity. Okay. This is an old PowerPoint, but if you open PowerPoint, you have all these series of templates. Okay. For me, the only viable one is. Okay. Because first of all, it was proofs that scientifically that the best background for readability is white. When you really want to read stuff. And from my perspective, it's not necessary to repeat the logos on each slide. Okay? I think it's nice to put the logos on the front, the first slide, saying, okay, this is the project, it's financed by these guys, etc. But after that, like Jean-Luc Dumont is saying, are you giving your own name at the beginning of each sentence? No, okay, you introduce them. I'm Arnaud. I don't need to say it in front of each sentence. So from my perspective, if you put it on all slides, you lose a lot of space and you distract the eye. This is an example of a project where we are forced to put this on the bottom. European project also a long time ago. First of all, it's a bit ugly, but that's my perspective. But also it takes a lot of space because my whole information is here and it will distract your eye because maybe you're looking there. There's no interest of doing that.
So with 7 logos, okay, but only the last one maybe in each slide.
So I agree that if you don't want to be as extreme as me, you can put one logo, but don't overdo it. Don't have a full line taking half of your slide of logo. Okay. Yes.
So for me, I would say it should be white, but when one person enters a room, they should guess who is coming, who is speaking. For instance, when you look to CA, when I enter a room in the middle of a presentation, there is not written C because I know. So for us, it's USES2 and Europe because it's funded by Europe. It can be very small, but really when I enter, if I don't know who is speaking, I know from where it's coming from.
Yeah, I never thought about that. I thought people come on time in meetings. But...
No, in conferences, you come in and out and.
There will be another reason. So some people also take pictures of slides because they find something interesting. I find it nice that they have some information. Anyway, I would say most institutions, I don't know about yours, but ours, they have a corporate design and corporate identity, and they are mandatory.
Yeah.
But so, I mean, I think we should not spend too much time on that. Just to give you my perspective. So because this is linked to the signal to noise ratio. I will explain later. So for me, but we are all humans, we are all different, and I'm not forcing you to do, giving you my perspective. If you are forced by an institute, by a project, by whatever belief you can put, but be careful that it doesn't take the whole space because it's repeated on each slide. So what's the point of losing all this space? That's my thing. Now, when you make a presentation, be careful about size and alignment. This is completely misaligned. This is aligned. This is an example of one of my students' presentation. It's all over the place. It's like this. It's like this. This is higher than this, wider than this. Looks a bit messy. And with PowerPoint, you can easily crop, resize. You have these guiding lines to know if you are the same height, etc. So just do the exercise and have something a bit more structured. So everything is aligned here, aligned here, aligned here, same thickness, same width. Took me 2-3 minutes to do it. It improves readability. So in the end, my template consists of 3 colors. I have 2 types of fonts. You can vary in title, and it's usually quite nice actually to have 2 types of font. It gives a bit more life to your presentation. So for my titles, I use this one with main title, subtitle. And then for my text, I use a didactic, whatever, choose your font. But this gives you your visual identity. And I have 3 types of pages. I have my main page of presentation, always the same ID here, but I can change sometimes the picture here, of course, depending on what I'm presenting. I have my section page where I told you I put these pixel images to make it a bit more lively. And then I have my general slide with just a title and all with this gray color that I use everywhere, black. And then I put some orange for graphical elements. So a word about what is visual grammar. Visual grammar is basically a way to help people understand faster what you are doing. Okay, it's kind of your codes for saying things. So for example, here, this is, I take again a slide that I showed before. What is visual grammar? Highlighting, for example, putting bold or underline. So if you use bold or underline, you can, but don't underline everything because then there's no point. Okay. Same for framing. I see sometimes all equations have a frame around it. What's the point? We don't see which one is important. Font size is also a grammar because if you see it small, you know that it's just minor information. If you see it big, it's a big title, etc. Okay, and so you grasp that. It's unconscious, but you grasp this grammar if it's well done. Colors, as I said, because here I use orange as more of a highlighting stuff for arrows or important stuff in my slides. Bullet points is also a way to do that. Arrows, etc. You can use additional elements. You can use icons. In PowerPoint, you have tons of icons. If you go to additions, illustrations that you make yourself, or just a bit more fancy illustrations also in PowerPoint. Why not emoji? You're talking about emotions. As long as you don't overdo it and it becomes a bit stupid, why not putting a smile somewhere because you think you did a good job? Maybe this one depends on the type of edit you have. You have cut-out people now in PowerPoint too. Why not putting a guy somewhere? It gives a bit of that. And you notice maybe I'm using some avatar sometimes with my students. The problem is avatar is that if you change your look, you have to change your avatar. That's why you see all the avatars in some of my presentations. I still have hair and no beard, and now you see some without hair and beard. Right. It didn't take time to adapt the avatar. Maybe there's an automated way to do that. Maybe I should talk to Florian about that. But the nice thing about these things is that they make it more lively. They replace the text. Sometimes you say, oh, it's a good result, so you put a thumb up or you put something like that. Gives a personal touch. It's your way of presenting, and it conveys emotions. But don't overdo it. Don't put it all over the place. Still scientific presentation. Of course, I already talked about this, so I'm just, it's part of the presentation. So avoid text and put illustrations. Figure graph I already said, so stay away from default things. Tell your story in your type with color codes, etc. This is, I already stressed that. Now equations, of course, don't put too many equations, depending on the level of technicity of your presentation. If it's a general presentation and there is no interest in really discussing the equation, don't put it there, just put the necessary one. But there is three ways, to me, three ways to do it. One is to use the equation editor of PowerPoint. I don't like it. You can also use LaTeX to do a PDF and then a copy paste, but the problem is that it's not editable. You always have to go back and do it. But there is a very nice add-on, if you know, it's called Iguanatech, and I will demonstrate it now. Iguanatech it's a free add-on to the PowerPoint. If I show slides, if I go to my equation here, banner on top, and I can. So here I have Iguanatech, and you see that I can edit my LaTeX display. This is just LaTeX code that you put there. So if you are using LaTeX for reporting, etc., just copy paste your equation, put it there, and if there is a mistake, you can adapt, you can change the size, etc. It's very handy. And if people don't have Iguanatech on their computer, they will still be able to open the presentation and see the preview because it stores the generated preview. They won't be able to edit it, but at least they will see it. So there is no problem of compatibility with that. And it's free and very nice tool. Since I discovered it, it really changed my life.
In fact, you can put any LaTeX code, so it could be a table.
Yeah, any type of LaTeX code you can put there. Sorry, I'm a bit lost with the banner.
Yeah, any full LaTeX.
Because you listen for fighting with your own.
Oh, you need to copy paste it, so that's automatically. Oh, you can copy paste it.
Okay. But that, can we separate charger? Oh, it's okay, I'm almost finished. Okay, pictures I already talked about. Crop, pay attention to blah, 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 recompose, etc. Now, the important point here, increase signal to noise ratio. This is the main message. No, I shouldn't say it like that, but this is a big message in the presentation. So this is noise, and this is signal. Okay, so basically when there is noise, you're a bit annoyed. The idea is that noise is everything that distracts your attention from the presentation. And signal is all meaningful information. There is a lot of different sources of noise, and so the idea is to get rid of that. So one source of noise I didn't maybe stress too much is that, for example, if you are putting a lot of text, if you're putting text on your slide and you're reading the text, people will try to read, and at the same time listen to you. That doesn't work. It's a double channel, so it's noise. There's one that is annoying the other. So never read exactly what is on your slide. It may be just one keyword and talk about it. So you force people to listen to you and not to watch. That's one source of signal and noise. The other one is on your slides, focus on the necessary information only. So everything else is noise and remove. So if you're not going to discuss a graph, a sentence, or something like that, don't put it there because people will look at it, they will wonder what it is, and they will lose you. They will not listen to you. So for that, there is a very famous technique. It's called the M&M's ball technique. And it was created by Jean-Luc Dumont. You can go to its website. There is really interesting stuff about presentation. Technique of M&M balls is as such. You prepare your slides, and then you wonder, is there anything on this slide I can remove so that my
I'm sorry.
Is there anything like this that I can remove? Because that was noise, okay? That was typically noise. So is there anything that I can remove till my message is clear? If it is, remove it, you can eat an M&Ms. Of course, if you don't like M&Ms, you can do it with whatever you like, pralines or chocolates. But the idea is to reward yourself for everything you can remove. to go really down to the minimum acceptable for presenting your work. Okay? I know it's not very good for your health, but if you start well, you shouldn't remove too much, or you shouldn't eat too many M&Ms. It should be okay. So that's an example of my student presentation in Master 1. There's a lot of information there. But what was the purpose of this? And you probably all are reading this and not listening to me at the moment because there is too much text. Okay? But and you cannot take out what it's talking about. So I'm going to tell you, it's talking about ultrasonic pulse velocity measure, which probably most of you are familiar with. Thank you, Stefan.
Move a bit, I cannot see the.
Is it okay? Okay. Yeah, Mr. Share screen. That's noise again, sorry. So the idea was to present what is UPV. So if I had to do it, I would do it like this. I would say, okay, guys, I have two transducers that are separated by a certain distance. This system here sends a pulse here. Then it measures response. And by computing the time of travel, I can get the velocity by the distance divided by time. That's all. So with just these two things, I can say exactly what's on the other slide, but I keep your attention because there is visuals and there is no extra text. So another thing about noise to signal to noise ratio is rhythm and animations. For example, here, I want to talk about two mass dampers, and to make it a bit more lively, I first present you the buildings, and then I present you the solution. What is the interest of doing that? Is that first I talk about this, and so you're not wondering, what is this thing on top of the building there that he is maybe going to talk after? Just I show you what you need to see. And then when I'm going to talk about him, I'm going to show it to you, to avoid that you go further. You know, in the old times, we didn't have PowerPoint, we had slides on this, I'm sorry, I'm the old guy. And my professors, they would put the slide, and then they have a sheet, and they would hide, so show the first equation, and then they would do like this. Because they didn't want you to read the last equation. They wanted you to follow their explanation. And it's very simple to do in PowerPoint. Just use simple animations. Huh? Because if you do an animation where this comes from here, bounces 3 times, comes back here, people will wonder, wow, how did it do that? But they're never going to say, really focus on what the image is about. Okay? So simple animation, don't make it fancy. So this is about the rhythm. Same example here. If I want to, even with text, you can do that, okay? If I want to explain things, if I put the whole text, you're going to read faster than me. So I'm forcing you to stay at the same rhythm as me. That's why this is very useful, and I use it all the time, because I can speak freely and just introduce information one after the other like this. Now, for the actual presentation, how to dress? First question.
So how much time do you need? What minutes?
Okay. How to dress? I would say just be respectful, and it depends on the context. Okay. So maybe don't go to that extreme. But you said today I'm dressed a bit relaxed. It's hot, so I put some shorts. But if I was going for a Nobel Prize, I would probably be wearing something else. But there's no Nobel Prize in engineering, so I accept that I will never get it. Anyway, so really be respectful, and it depends on the circumstances and also how you feel comfortable. Because if you feel comfortable with a tie and a shirt, then do it. Respect the timing. Well, I know I'm a bit over time today, but this is also because there were a lot of questions. But in a general jury presentation, you have to respect the text. Number your slides. Why do you number your slides? Because if there are questions, people have to tell you, oh, I have a question about slide 12. So if you don't number your slide, you can say, oh, I have a question on the slides where there was a picture of rehearse at home, because then you know how much time it takes, you know what to speak about. Speak slowly. If you go too fast, and people may, because you're nervous, so you're going very fast. It's not a good idea. And focus on memorizing a bit more what you're going to say in the first slide, because that's when you're the most nervous. But most importantly, read and remember that we've all been there before. We're not going to overjudge you for not being able to present well or making some mistakes. Okay. Fast element. I'm not for table of content. Why? Because you gain some time if you don't put a table of content. And secondly, if you look at this, There are technical words, reasonalizer, blah, 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 blah. If I haven't introduced my context, if I haven't defined them, you won't know what they mean anyway. What's the point of doing this table of contents if half of it is not understandable anyway? I don't see the point, okay? And very important is your strategy. So the strategy should be telling a story. The strategy means that you have to construct your story around your message with the goal to deliver the message. If the way I usually see students presenting is linear description. So it means, oh, I did this, and then I did this, and then it didn't work, but then I did this also, and then I tried this and this and this. This is a linear description of your work. And what's the point? Is to convince us that you have worked a lot or to convey a message. So it's not always the best way to present is to do in a linear way. You have to think really freely in your head, how am I going to convey my message? Which elements do I need to introduce and in what order? So I'm leaving these videos for you after because anyway, but there will be the links. This is about how to speak. Obviously, if I was speaking like this to you all the time and looking at my feet and so, you wouldn't be very interested. Okay. Also about we discussed about the body language. If I'm always like this and not moving, it's not very lively. If I'm not looking at you sometimes, all these things. And so, as a summary, have a message, make attractive slides, increase the signal to noise ratio, and enjoy your M&Ms. Pay attention to your body language and respect as much as possible the timing, but most and for all, spend the necessary time. There is no miracle. If you don't spend the time, you will have a crappy presentation. It's like everything in. Thank you. Do we have time for a few questions or are we have to go?
Thank you very much.
A little bit behind schedule.